5 more minutes.
And so you have to define, self-define like IDs, all of those things like that.
One that's been in that information about
here
I'm not a security guy, so I don't understand. I can understand how much people are complaining about it. Oh, have you tried this?
Okay, go ahead. I can talk whenever you want.
Okay. Thank you all for coming out. We will probably have people trickle in for the next 15, 20 minutes or so, and then kind of level out a little bit. But, really appreciate everybody being here tonight. We have a few things coming up, including some things going on as well. And in a little bit, we'll have Venkat introduce himself and MapR and who they are and why they're here, things along those lines. But right now, we do have a couple of big data competitions going on. Is everybody in the room familiar with those? It seems like most people are. I'll just do a quick recap. So we have one, a Taylor Swift competition. Okay. I don't know how that happened. Yeah, we'll say that we let you guys create it and therefore it's your fault, but that's not it. Really then went, oh, I think she's cute. So what we're doing is we're predicting Taylor Swift and whether or not one of her popular songs is going to be popular. So you'll have a data set that you can review. You can look at, what was it, 3/10 of a second at this point? I know he said 1/10 at one point, but I don't know.
It's a little bit longer. It's been downsampled it a lot, and then it's a little bit longer. It's just under half a second.
Just under half, okay. So to be able to look at it that quickly and be able to determine whether or not that's going to be a successful song, that's cool. And there's a lot of potential things that can be created from it. So please spend some time there, check it out, check out the code that's already out. Check out Meetup and other places. If you can't find that information, feel free to reach out to me directly and I'll try to provide that. Also, we have an OC Tenor competition. Semi-ironic that we're here tonight. So OC Tenor has provided some data for us to be able to look at appreciation awards and determine if there's a ripple effect when somebody gives out an appreciation award anywhere around the world. So it's a pretty cool data set to look at as well, and there's some things that you can start applying that to, whether it's customer referrals or other things out there. Plus, if you want to go steps further with it and try to determine some additional things, we'll have awards and other types of prizes and gifts for different paths that you guys take. So there are events coming up. We've got some pretty big ones here. Thankfully for February, I think we're good until next Saturday.
Next Saturday.
Oh, no, we've got tomorrow too. So tomorrow's the Hadoop lunch
Yes.
at Adobe, so please come out to that as well. Then we've got a break till Saturday.
Yeah, and it feels like I haven't been here for a month, but because I missed last week. So SharePoint Saturday is coming up next Saturday, the 28th of February. You can get all these at utahgeekevents.com. It's coming up next Saturday. There will be lots of great prizes there, lots of great events, all on SharePoint, all revolving around SharePoint. It'll be at the University of Utah Spencer Fox Eccles Business Building, same place we do the Code Camp and the Fall Big Mountain Data. So that's 2 weeks away.
Quick little secret about that, SharePoint is a pain in the butt. And what that secret means is that there are a lot of companies that spend a lot of money to do some really cool things with SharePoint, or some not so cool things with SharePoint. So you may want to show up just so you can pick up some cool projects or talk to some companies that have some cool things that they're really frustrated with.
It's going to be a lot of fun. It's going to be a good event. We're planning for about 200 people. So, like I said, it'll be a fun event, free event. Come out, join the group. Just register on their site. They have a Utah Geek Events has the link for it. It's right here on this page as well that I put on all the tables. Then the big event coming up is Code Camp. That's March 14th, so that's a little less than 4 weeks away, or about 4 weeks away, something like that. We are still looking for speakers for that. So we would love to have people to come out and speak still. And we're looking for unconference ideas. There will be an entire track that day that is basically open to whatever the community wants to talk about. On the website, when you go to utahgeekevents.com, you go to sessions, there's a section there called unconference ideas. And you just say, add an idea. And you put in whatever you want. You can talk about any topic you want, whatever it is. And you don't even have to present on it. It's just saying, I would like to talk about this topic. As the schedule fills up, we'll take whatever the highest voted items are, and that's what schedules are going to be scheduled for that day. And it'll be a whole track all day long. Whatever people want to talk about in that room for those ideas, that's what's going to be in there. So
Please don't pick Taylor Swift.
The competition will be fine, but not the person. Let's keep it to technical topics, please. But that's the idea. The unconference idea is basically there so that as a community, you can submit whatever you want. You can talk about any topics you want. So we're also still planning. There's possibly a kids fair going on during Code Camp. There might be some other things going on. There's still a lot to be planned for Code Camp, but what we really want to see is more speakers and more people out to it. So go to utahgeekevents.com and pick it up. The other event that's not listed on here, another big one coming up, besides Big Mountain Data, which Nick and I will talk about a little bit. Big Mountain Data, we're still planning it. There will be a spring event. We don't know if it'll be April or May. We're working on it right now. We will let everybody know as soon as we have it. It'll be similar to one of these other events. And then Open West. Open West is coming up in May. May 6th through the 9th, I believe, or 6th through the 8th is the weekend. And it's a huge event. It goes on at Utah University. Really cool. They just put up all their speaker lists too, or their session list. You have to go vote for them. So go out to openwest.org and vote for what sessions you want to see. And then register as well. I don't know if the registration's open yet or not, but either way, that'll be a really cool event. It's definitely something to go out and see. It's openwest.org. So.
Yeah, between Code Camp and Open West, you're talking about the biggest tech conferences you're going to see here in Utah, Tech Agnostic and Open West.
Yeah, Code Camp's open to all technologies, all speakers. We don't care what you're talking about as long as it's technology. That's what we really want. We want a diverse population there. We want one room talking about, say, SQL Server, one room talking about Mongo or something. We want a complete diverse population. That's the whole goal. So, okay, those are the only ones I have.
All right. Questions about anything that's coming up? Okay. All right, if you want to introduce yourself.
Good evening, guys. You guys already know me before. Like last week, I came here to talk about the drill. Today, I'm a senior data engineer at MapR. MapR is one of the leading distributors for Hadoop. So there are three competitors. Basically, I want to make sure that there are three competitors in the Hadoop world, which is Cloudera, and Hortonworks, and MapR. So MapR works on it. Basically, there are three distributions having three ideas. So Cloudera goes like a subscription model. Hortonworks goes as fully open source. MapR has different IPs. So basically, whatever the Hadoop system like HDFS or HBase has problems, we kind of created some IPs around it and made it like a community subscription-based environment. So those are the topics today. We are kind of, MapR is kind of heavily investing on Drill. This is one of our pet projects. Today we're going to talk, last week I talked about what Drill is, how it works. We deep dive basically how do you communicate with the drill bits, how actually the whole scenario of SQL querying and everything engine works. Today we're going to talk about demoing how it is easy to use the Drill. So I'll be trying to go on 2 use cases. One is last week I kind of showed up some use case regarding the help. So I'll try to use the same use case, and I'll try to go on some of the retail use case. In that retail use case, basically I'll try to get combine data from different data sources and try to query and do some things and see how really it's easy to use. So today's agenda. So we'll see what is Drill. I think you all and installing and configuring the Drill. If you want, you can walk through with me. It's pretty straightforward. You just need to download a tarball and then you're good to go. And I'll try to go to the data sources, each data source. We'll see how we can use, how we'll be using demo, and we'll try to see what's coming in the Drill. So key points for the Drill. Drill is a distributed query engine. So basically, when you talk about Drill, it's a distributed engine wherein when you run a query, it basically goes to all the drill bits. We call it drill bits. It goes to all the drill bits and query executed simultaneously on multiple nodes, and results are written back to the client. And it's a dynamic schema. There is no schema when you're writing an SQL query. You don't need to worry about schema, whether you're doing SQL, MySQL or Hive or HBase or MongoDB. It's a schema is dynamically, you're querying a JSON object, Parquet, Avro. Schema is dynamically evaluated. And that's what we meant by dynamic schema, scale out. So as we keep on adding the drill bits, like agents and nodes, your query performance will be scaled out. And low latency. The Drill has been built from bottom up. Everything has been, it's not like taken from and use it as a separate project. It has built from bottom up to make sure that low latency is the key feature in that. It's extensible. When we talk about extensible, basically what happens is Drill can be used. Drill is nothing to, is no link to the MapR or any Hadoop distribution. Drill can be used with any of the storage systems. It can work with MongoDB, it can work with MySQL, it can work with file system, or it can work with Hadoop. So, but Drill is more optimized for using its Hadoop and Parquet and Avro formats. And JSON is the basically that's what we are trying to go. Goal is go to the JSON object, because JSON is by default is a self-describing data type, and we support all the industry standards and SQL. The main goal of Drill is here is that we talked about last week. What's the main goal of the Drill? We want to put the data scientist on the front side. So they should be, if they have different data sources, like having a data in SQL Server, having a data in Hive, having a data in MapR DB or HBase, they should be, or in the files or log files. They should be able to combine all these data points and should be able to do the query on top of that without having anyone doing the modeling behind it. They should be able to do the search and do try and errors, and should be able to create their own views on top of this all the data points. So we'll go with the installation and configuration deal. Drill is pretty, running Drill takes around 10 minutes. These are the steps actually. So you just download the tarball, choose the tarball, and start the Drill. Drill can be can run as a local mode or as a distributed mode. If you run it as a distributed mode, you need the Zookeeper. Zookeeper is the one who maintains the state between all the drill bits. So today we'll go to. I'll try to show both ways, distributed mode and the local mode. We'll just go with the local mode first. So I already downloaded the tarball actually. So
Did that for some reason stop your presentation?
sorry, I just stopped it. I want to show the more.
Yeah, it didn't. It seems to have stopped it. Sharing. Did it close that window, maybe? Yeah, I think something crashed in the background. Give me 1 second. Oh, there it is. I don't know what happened. I guess it just stopped. Yeah, it loves to do that. There you go. Go ahead. Sorry about that.
I downloaded tarball, which can be downloaded from the drill.apache.org, and I took the data set from the help. Help has a challenge for data set. I just downloaded the data set from the help guide. So I'm using that data set to run the queries. This is the data set they are providing. Like they have different. So drill help is kind of providing the data set wherein it's a reviews. What are the what kind of reviews are there for what businesses and all stuff. So if you look at the data set business is basically self-explanatory. It's too big. If you look at the business.json, it has all the business, like every business has an ID and what kind of hours it works and what are the categories it belongs to. And it's self-explanatory JSON object for all the businesses. It has attributes like whether it support alcohol or noise levels, what is how it looks and all that. So that's how that's what object data is self-explanatory. It's all JSON. Just trying to use the same thing. So once I download the tarball, I went into the tarball and I just ran the SQL line. I'm running the bin SQL line. Basically, that's the command line utility for drill. It's supplied with that drill bits, and I'm connecting the local. When I say ZooKeeper local, it starts its own ZooKeeper internally and runs it. So I have too many things running. Started and it went command line. Now you should be able to do the query. So let's do some queries on top of the data we already had. So did you see the query? I'm just basically going through a select start from. Can you increase the font size? Sorry?
Command with the plus, it should go. Command and plus. Yeah, it is increasing.
Okay, thank you. So if you see the query, there is no. I haven't provided any data type or anything. I'm saying select star from DFS is the default namespace created. It's basically default database setting. I'll go through how the storage engines are configured and everything on the next page when I do the distributed. DFS is the default one, wherein it directly goes to the file system. And you can see the whole path I have given, which is a directly reading the JSON object, and I said limit 1. So basically, I want to see the first object on the sphere on that file, and that's how you can see the first data object. You can see the first data object was queried in there. So it's that easy to start and using the drill and going through all your data files or any JSON or Parquet objects or any plain text files. The drill supports the NCSQL, and here I'm trying to determine the data type. I haven't given any data type or anything here. It's a pretty simple query. I'm trying to say that give me all the sum of the reviews, how much review counts for all the data set on that JSON object they have given us. It's about around 500 MB. I'm just giving a sum of all the review counts. And that many reviews are there in that just one file. 1.72 billion. 1.7. It read through that 50 MB file in that less than a second. I want to show the group by or order by as well. This is one more query wherein I'm querying saying that select state and city, and seeing that what are the total reviews for each city, and I'm order by in the count start, taking only the one which are on the top, and limiting by 10, and I'm grouping by state and city. And that's the result. So with, what I'm trying to say is that as a drill, you don't need to know any data types or anything happening on the object. You should be able to query creating the file. You can directly write a file. If you know the file, you can just go and say select star, and from there you should be able to navigate on different data types or different operations you want to do it.
Is there some sort of way to get, say, the headers or?
Yes, you can use the description. Explain is a command. Is a you can.
Venkat, do I need VMware Player or VirtualBox, that kind of thing?
Did you catch that?
Sorry. Oh, sorry.
Do I need a VirtualBox or VMware Player?
Got this one?
Yeah.
I'm not running any VirtualBox. I'm running it local. I just took the tarball and I just downloaded it, opened the tarball, and I'm running it as a command line utility. You don't need to have any VirtualBox or anything. If you are looking at the distributed mode, which I'll be going next, in that situation, I try to use a virtual machine because I have a cluster installed on the virtual machine. So right now it's running on local mode. Everything is local. There is no installation or anything. I just downloaded tarball, untarred it, and ran the command like SQLite, and then it's connected to the local. It started with one local zookeeper and the local drill bit, and you should be able to query on that top of it.
What is the architecture behind this?
Like
When you run the query wizard, what kind of architecture it has?
What understanding?
for running the, for basically you want to know how the drill works.
Yeah.
Last week was that last week we explained about we talked about it. I can show it one again. So drill supports the JDBC, ODBC connections. We have drill, we call it as drill bits, like agents running on every machine. So wherever the data is there, where you can run the, when you're running in distributed mode, you might be needing some different workers to be running it simultaneously. So we call it drill bits. You can run those drill bits on a distributed mode on multiple machines. And any client should be able to connect using JDBC or ODBC or REST API. So all the communication happens through all this. When the drill bits are like, you have n number of drill bits, there should be a communication between the drill bits. Everyone should know what's happening with the other guy, where the other guy is there. So all this communication happens through Zookeeper. Zookeeper maintains the state of all the drill bits. When the client tries to connect to the cluster, he first goes to the Zookeeper and check, and basically he'll be assigned one drill bit. That drill bit will be the master for that client. As the new clients come in, he'll be assigned a new drill bit. So there is no master or slave kind of architecture here. Every drill bit is a master, and there is no that way. What happens? There is no single point of failure. So when the client comes in, he'll be assigned one drill bit. For the whole communication happens to that drill bit. When the drill bit, any of the drill bits in the cluster dies, the drill bit which is key connected, will take care of rerunning the query on that particular drill bit and reorganizing the data and sending back. So last week we talked about optimizations. Some of the optimizations we did on the drill bit. It's called optimistic optimization. We always think that none of the drill bits died in the process of running the query. So we never maintain any state or anything internally in the drill bit. That's how actually the whole communication happens. So I'll take you through that. Another slide wherein this is what internally happens. So when you submit a SQL query, this is one drill bit. Underlying what's happening in the drill bit. So the drill bit has RPC endpoint. So when the client goes to Zookeeper, we'll be assigned a new drill bit with his port, and he'll be knowing the server and port. The client will connect to the RPC endpoint to that particular drill bit. When he supplies the SQL query, we are using a QPy open source SQL parser. Basically, what we do is we take the SQL query it has been sent and create logical plan. And we have some on top of the logical plan, we have the optimizers. Some of the optimizers are like when you're looking at Hadoop, data locality is the main important thing. So because as a MapR, what happens is we kind of provide everything. We don't want to say we support this thing or we don't support this kind of. So we want to make it if everything is open source, everything is supported. But there are some drawbacks on the Impala or Hive or anything, which are kind of addressed in this situation, and that's what it really is all about. They want to make it more open source and more flexible enough for using a different data sets. So pretty much it's you should understand all these SQL queries. So it supports all the functions of SQL like trunc, average, sum, mod. All those functionalities are all whatever the ANC SQL is there. It supports all. So here you can see that I'm basically going into the file system and grouping the star and ordering by star. And as I do the average, I'm doing the truncate function on top of it so that I don't see all the double digits. If you remove the truncate, you throw the doubles. So you can see how many stars for every business there are like 5 stars, like 8% of the on average 8 people get the 5-star, 4.5, 4 is the max. So you should be able to drill down on the data sets you have and do the query, and data sets should be able to use this data. So all this data is pluggable through JDBC, ODBC. So you're not stick to the command line. If you have a BI tool like a Tableau or anything, you should be able to use the JDBC connection and connect to the connect to the drillbit, and do the queries on top of it, and you should be able to visualize all those data. Yeah.
So a lot of those kind of require metadata.
Sorry?
A lot of those like MicroStrategy requires metadata, right? But
there is no metadata. We don't require any metadata. We dynamically recognizes all the metadata. There is no metadata here.
Great.
Yeah.
This is so kind of that. Would that kind of exclude tools that do?
No, because we support both. Let's say if your Hive is there, we work on the Hive metastore. So if you already have it, if you have a HBase, we work on the HBase schema.
Gotcha.
So we are not restricted. Like if you don't have a schema, we'll work with it. If you already have a schema, we work on that. So Parquet and Avro has inbuilt schema. We take the schema and try to do it. If you're using a files, there are no data types or anything. Those data types are determined on the runtime. Yes.
Sorry to take you back to that. So if you have giant queries here,
yeah,
how do you manage that in memory?
What we do is we try to have just like Spark SQL, we try to kind of spill onto the disk.
Oh,
yes, yeah, we try to do it as much as memory as possible. But as if you have a setting of memory saying 2 gigs per drill bit, if you're exceeding that in memory, we try to spill to the disk. That will increase the latency, but your agent will not die. So that's one of the drawbacks in Impala. Actually, Impala doesn't do that.
Yeah.
So you have to have a data set, smaller data set to do the joins.
Yeah. So it's the same here as well?
Basically, here we do the spill.
Okay.
So if, let's say you have a 10 gig files you want to join. Yeah. That way, what happens is you have only memory which is 10 gigs. We try to put as much memory as in the memory, and try to spill the rest of it onto the disk.
But is the distributed across remaining nodes?
Yes, it is.
So
That is always
using all the memory.
All the memory on this. So we try to do as much localization as possible. If the data is everything is one node, we try to have network I/O, and all the drillbits will share the data.
So and are you able to sync with
so if you see
Mesos or any?
Sorry.
Are you trying to sync with Mesos or Tachyon and other stuff?
Yeah, Mesos is something which is coming. MapR is next pet project is Merrick, which is coming as a Mesos. So it's a underlying technology. Everything is support like creating the cloud on top of creating a cloud infrastructure visually on the Hadoop. So that's what it's all about. So if you see this one on the slide, we have a distributed cache layer. So if you have it here, we have an endpoint and we have a distributed cache layer. That's what I'm talking about. So we try to put as much data as possible, and we strike it because it's not fully distributed. It's not fully cached, because if the data is going beyond your drillbit memory, we try to split it onto the disk.
How are temp tables handled?
Sorry?
How are temp tables handled?
How are temp tables are created? So
Yeah, in SQL you're going to create temp tables all over the place.
that's something, I don't know, I can check it out.
Yeah. They have to do something. Especially if you use the MicroStrategy.
Drill supports NCSQL, wherein you can have internal SQL queries. So you can query one data set and have it as coming as an internal data set. So if you see this one, what I'm trying to do is I'm trying to query on the names of the data set here on the businesses, but I'm trying to select what business I need to show, saying that the business is having the votes as pool more than 2,000 and some order by sum, so that I'll pick up only the latest ones. So I'm running a query here and supplying it as a in to this one. So business IDs in that set of IDs are got it. So it supports internal, just like SQL, it supports inner SQLs. Inner SQLs will take a little bit of time. So that's how it is easy to use the drill. If you have any files, JSON files or Parquet files, you should be able to directly use the drill, do some queries, the text star and all stuff. You should be able to see what data is there. Based on that, you can drill inside the data. So let's say if I say select star business. Now, if you see this one, I have data type hours. Hours is basically has Tuesday, close, and open, and it's a JSON object. So hours is like a JSON object in the inside that. So when you want to do the query or anything, creating a view or anything on top of it, now you should be able to say that, okay, I'm interested in select hours dot Tuesday. Sorry?
Is it hours type?
Hours. It's not hours type. That's a. Okay. Yeah. I want to make sure. Till getting this stuff, getting used to it. We have everything on the site. Okay, so everything is available there. So you should be able to launch it and see everything here. something like that. It should be able to. There are some data types which are null. Take out the throws. But there is no data for certain entries. So usually you should be able to see that data is like close. You kind of got inner SQL kind of part of it. So here it's like you can say Tuesday. I think you have more.
If you we had that select b.hours.tsig. If we did select b.hours.tsig, comma b.star, would that run? Okay.
B.star? Yeah, we can try.
After, comma after.
You want to see all the columns and everything, yeah?
Yeah, after the.
Yeah, I think it should. Yeah, it should go. It listed basically that came as the first column, and it listed all the columns, all the data. Let me put it as one. Let's see. So the first column came in as whatever is selected here. And then so there are commands like flattening. So most of the times what happens is you might have the data which is categories. I want to show the categories. Let's see. No data types. So why you take the category as a business star?
So since it's kind of schema on read, it would just return a null if you gave it a column that it couldn't find.
Basically, there's no data for that row actually for the scheme. I think that's a.
Well, I think you said category though, not categories.
Did I?
Yes.
Okay. That can be done. Yes. So thank you. Yeah. So you can see that trying to get you the array of objects there, and you should be able to flatten. Basically, what does flatten does is it creates a separate row for every category entry. So if I try to run it as a flatten, that's how it looks. Basically, you can see that every business comes into different categories. And you should be able to query or order by those categories and get the count, how many are there for shopping category, or how many are there in the bar. And similarly, you can attach to the number of reviews or stars or counts by state or city. You can write your own queries on top of it. As a data scientist or anyone, they can write their own queries on top of it.
So, yeah, in the case where you said category instead of categories, it seems like that would make it kind of hard to syntax check or anything like that because there's no
data in there.
Right.
Yeah.
It just kind of says, no, I didn't find that, and you get a null.
No, yeah, we try to make it as dynamical as possible because if I make it as category, the data file I gave might not have category, but the data file which is coming next time might have it.
Right.
So we want to make it a schema free. That's what we meant by schema free. It's not like we are not bound to the model we create. The data point that row is not there, we make it as null.
So you kind of, in some ways, you kind of defer an error, though.
Yes.
Right. It's kind of like the statically typed language versus the dynamically typed language problem, right? Okay.
Yeah. What happens is, if, let's say you added a new column or removed some column, the query should work.
Right.
It should not like not like bomb or something.
So when you have a large query, let's say large data sets and you are running a query, it takes some time. So do you have any tools to monitor that query?
Yeah. There are tools where basically MapR comes with monitoring tools. We use Wadik, which has information like what the query is running, how much time it is taking, what phase is there. So for every drill bit, you can go and say status. You can make it as an RPC call and say what's the status. It will tell you what's the status of the running query.
It's part of the open source whatever we have downloaded.
Yeah, everything is open source. There are some optimizations which are kind of helps in MapR stuff, but those optimizations are also in open source, which can be used as components to other data sources.
This is independent of Hadoop, so we will have only drill installed.
Yes.
On that particular server, we can have the monitoring tool. Is it correct?
Yes. Yeah, monitoring tool, status and everything comes as a REST API. There is no tool built on the REST API. So you can connect as a REST API and see the status, but you can't like UI and everything. They're kind of everyone is developing their own. It's kind of incorporated into our management console. So data is available.
Okay.
You can write your own REST API calls and read those statuses, and you can see from the status you should be able to know how many drill bits are down, how many are working, and how much time each is consuming, how much memory it has. All that information is there on the REST API. Only thing is how you query is we created our own UI, which is incorporated into our management console. Where in one place you should be able to see everything. If data is there open source, people can create their own stuff on it.
So an advantage to being schema free is that you're not going to have to worry as much about the data being normalized.
Yeah.
Exactly how your schemas are set up, right? But is there a fast way to get through things where, like in my location, in one data set is the city name, another one that's like an abbreviation, another one that's a zip code, another, is there a fast way to get through all of those different?
You should be able to join those data types. Like say you have let's say you have a MySQL database as a city, and in other database you have as a zip code. You should be able to cast it. You can cast it to different data types you want, and you can do the join on top of that particular data types. So I'll show it on the distributed mode. How do I? So the next demo is basically about the retail. So how the just a use case like how the data scientist comes in, sees a data set in different presets. We'll run some queries on top of the data set. Crashed. So. It's pretty simple use case. So there is a retail kind of thing wherein you have customer information and product information on the MapR. So basically they are saving it in a NoSQL database, and they have a click stream like how many clicks are coming and everything, which comes as people save it as a log files. That will put it as log files, and there is orders. All the orders happening around. People try to save it in time. So I'm trying to all this explanation is all of that one. So you can see that some data is in MapR, which is HBase, and some data is in file system, and some data is in high metastore. So you should be able to combine those queries and should be able to do some queries and see how you can use drill in there. So it's continuation of the same explanation. How the data scientist analyst should be able to drill to all the all the data points and should be able to query. So for this one, I kind of installed the sandbox. MapR comes with the sandbox. If you go to the mapr.com, and there is a drill sandbox which has everything installed, and there is already a lot of sample data inside, wherein you can play with all of this HBase, Hive, everything is installed inside, and the drill bit is also installed. Everything is installed. You can just pretty much directly take the install the sandbox, and should be able to run it as a distributed mode or query or a cluster mode if you want to see how it works on the Hadoop. No, not an M7 only, but it's sandbox. You can't use it as a commercial. Everything is there, but it's a sandbox. You cannot install on the machine. No one explained. So how do we maintain? So this is a drill UI. This is how the drill UI. Drill bits runs on the port number 8047, and you can basically get the drill UI. So this is similar to what the other people like Paula has the same browser kind of thing, where you can run your SQL queries, create your own profile. Profiles and everything is not in there yet. Security, as the security comes in, it fills in more information. So I'll talk about the metrics. As I said, you can see the using REST API. You should be able to see all the information, right? So this is basically the REST API call made to the server, and you can see all the information on how many counts, are there intent logs or anything, all the debug information. You see how much heap started with, how much right now. You should be able to see how many drill bits are there, how many dead. This is all coming through REST API. This is just a web page, which is basically doing the REST API calls to the server. So I want to talk about the storage plugins. So how do you define what data source to look at? So right now, by default, you get it like DFS, which is like file system, keep talking. Yeah. Right now we have file system. DFS is file system I just created. I'll show you inside. There is a data type called hide, and there is a data type called MapRDB. And there are some disabled configurations, HBase and MongoDB. If you have a MongoDB cluster, you should be able, you can enable that MongoDB and should be able to do the query on top of the Mongo storage plugin is already contributed. It's there in the part of the package. So writing a storage plugin is pretty easy. There is an interface to install, and you can just once you implement the interface, you can just drag and drop the interface on jar file into the lib folder, and at the run, and you start a drillbit. At the startup, it just will go scan through all the interfaces, and it just loads those storage plugins into the memory, into the drillbit, and they are ready to use. So so this is a drillbit. If this is how data type is there. We define what type is there. Every time you do that, you will define. So when you're looking at database, what we have a database name. Similarly, what in Drill we do is every time you create a new data source, we create it as something called database. We call it as a DFS. DFS is a database for me right now, and you can create different workspaces. So what I'm trying to say, I'm saying that I created a data type called file, and I'm trying to connect using MapRFS. You can connect to the HDFS as well. There's no difference in you can use this MapRFS, you can use HDFS if you're using on any other distribution. And you can create workspaces. So what workspaces basically use that under database DFS, you have sub databases which are called root clicks. So you're trying to create a different directory target location. So when I try to use something like dfs.clicks, I'll be accessing files in this folder. When I say .logs, I'll be accessing this folder. So I created different workspaces, and you can define the data input type as well. If you want to define like if you're using Parquet or Avro or JSON, you can define the data types here itself directly on the file. So it knows what data type it has to read. So these are formats. So you can basically we define the format upfront. We said any file which is having PSV or CSV or PSV or Parquet or anything, we take it as a extension and saying that if it's .json, it's a type of JSON. It's a .MapRDB. It's a type of MapRDB file, Parquet or any other file. You will be defining the data types. You can these are extensible to different sources. Right now, these are the data types file types we support, and it can be extended to any type. If you want to have your own XML or you're having your own data type, you make it like this. If you want to, you can write your own serializer and attach to that as a different data type. You have a binary format files. If you want to search through or scan through, you can write your own data type, serializers data type, and should be able to use it. And there's one more data type. So it's pretty straightforward. I'm trying to connect to the metastore. So as soon as I connect to the metastore, I can see all the data tables under the hive. It's pretty straightforward, you know that. And MapRDB is like HBase. It's similar to HBase. It's the type of HBase, and it has all the combinations enabled or anything. And you can when you're talking to the HBase, you need some configurations to be able to. When you're talking any data type, or if you want to pass some configurations to your data source, that's where you put your config. So in our case, HBase, MapRDB, what happens is we have something called volumes, and every user can create their own volumes and create their own tables in their respective volumes, like a security model. Like in HBase, whatever we create your own data type, everyone can access everyone. So we have our own security model inside, and you should be able to tell what mapping to use. When you create a table, it goes to our HDFS or MapRFS location, where is the volume you want to get. You can allocate the space, how much space this table has to use, and also there are some settings are there. For that, we need that mapping. to know exactly which folder it has to go and read the HBase. So we are kind of passing those information on top of it. So that's how you define the data sources. As soon as you install I'm right now on the sandbox. So I'm directly running the SQL line, which basically connects to the local zookeeper. And it usually what happens is all the information about drill and everything, like how it default connection has to go, will be on the config. So it knows that what zookeeper it has to use and what port it's running on, what's the cluster ID, and information. Different settings are there. You should be able to go online and see different settings, like different optimization settings are there, like how much memory it can use, how much memory it can block, and what is the failure scenarios and all that stuff. You can put it on the config.
Question.
Yeah.
So when you got Hive behind the scenes, Drill is basically just going to the metastore to find the file locations and then the column, column names.
But no, right now what happens is once you have the Hive metastore, it knows where the files are there. It goes to Hive metastore, it knows the file where it is there, and then it goes to the file.
Gotcha. Would we still see the same sort of behavior where if you requested a column that didn't exist in the table, it would still pass it through it? Okay.
Yeah, we can try it that one.
No, that's okay.
So SQL line is our command line utility. Yeah, it's taking a little bit of time. Okay, so it connected to the zookeeper, it has connected to the drillbit, and we should be able to say show databases. So yeah, you can see that we have created a default Hive. If you don't create any workspace, it takes as default. Hive is a database, and we have a default, and we have created different workspaces like DFS with logs, DFS root, and clicks and temp, and we have sys for all the information about the user tables and everything. We have MapR DB, and CP is the class path. You can search on the class path. We created a data source wherein you can do the class path search. So basically, it does the class path search. If any files or anything on the class path, you can directly able to search. So let's go on the Hive. Use Hive. Similar to what and select show tables, and it has orders. So in this data set, I'm trying to have 3 different sources. One is Hive, wherein all the order information is there. The retail, when you talk about retail, we talked about like orders are there, and customer and product information is there in one place, and we have logs, clickstream information in one place. So if I go here, like use. Right now it's all files, I think. MapR DB. It goes to the HBase and it picks up all the tables in there. You can do the select star on top of it and see what the data type is there. So there are some of the queries I'm just trying to run. It's like running the clickstream. Directly going to that file and searching that information on that file and showing the data there. So pretty much like I'm trying to show everything like SQL queries on every data type. So it's similar to what we have seen previously. I want to show you some.
Can we? Sorry.
Sorry. Yeah. Let's say we have nested in logs. What happens is here, if you see the log data, we have sorted the logs based on the folders. Every year we have separate logs, and in that folder we have dates, and in that date we have files. So what does, when you have this kind of files, everything, what Drill does is it creates each folder as one column. So when I say I went to logs and I said select star from logs folder limit, you should see like dir1, dir2, dir2, dir0 and dir1. That's the folder structure you can build. So now you can do the query on those top of those folders. So if you say, let's say I'm interested in only 2004, you can put a where class saying that dir0 is equal to 2014. You can go to that folder, or you can say dir0 equal to 2012 or greater than 2012. So you can go up to all the folders it has, or you can do it at the next dir1, which is a date, and you can say I'm interested in 2014 for this folder for this date, and you should be able to do the where classes on top of the data type. So when looking at the folder structure, it creates its own columns for each folder, and it's putting up all the data in there from that files. I want to show you like how to insert the data into the table. Let's say this is a pretty simple query. I'm creating a table test2 and saying that select star from logs limit to. Let's say you are trying to create a subset of data or anything. You can, just like SQL, you can create a new table on top of the table, and that file will be created with that data in there. It supports. Yeah, that's what we talk about ANSI SQL. So there are two rows have been written. I can say select star from and that's the data in there. So I'm inserting that. I'm querying on a different folder and trying to insert it into a different file, different table, which is a different file.
It might have created a file for that in that directory.
Yeah, you can check on that. Okay, good. Yeah, basically it creates a directory in there and it's available for us to build. And you can similarly you can use a Hive meta store. If you say if you want to create in Hive, it will create in Hive, or if you create in MapR DB or HBase, it will create in that HBase. Yeah, it's a concept. So let's run something like query taking all the three components. So there's a cache function. Right now we talked about there is no data type or anything for any of our data. So you can use it. There is a cache function wherein you can tell what data type it has to use. Drill by default does the optimization and tries to identify the right data type. But if you have too many nulls or anything, it might interpret something else. Let's say you're looking at a int, but you have too many nulls. It tries to take it as a string, varchar, instead of taking a int. So you can tell it as well. You can use a cache function to tell it that convert that into int and try to use that. So it's pretty simple. It does a query on top of it and plus the data.
question.
Yes.
Can we use two databases? Let's say one is Hive, another one is.
That's what I'm going to show you now. So right now, if you see this one, I'm kind of going to the MapR DB and I'm calling the customers table. Now now I'll show you how do I convert kind of combine customer information to the order information which is on the Hive and to the clickstream which is there on the logs. So you should be able to do all those joins data types from different data sources. So it has a regex function. You can use regular expressions on the URL itself, and it supports UDF functions. You can write your own UDF functions and should be able to parse the data and do some serialization. If you have a field which is an object, you can write your own UDF to convert it, just like regular expression that previous. You can create your own UDFs and should be able to use a UDF to convert your data type into your own data type or do some manipulations on the fly. It supports all the UDFs functionality which is already there in Hive. You can directly load the Hive UDFs if you want. So this is the query I'm trying to create. So I'm trying to first I'll create a views. Let me go to the there. I'm creating a view. Drill comes with view. You can create your own views. Let's say when you're working on the data set, different data sets, you might be creating tables, creating a new data set between like combining different data sources. So you should be able to create a view using those whatever the query you have used, and you should be able to directly query on the view. So here I'm basically creating the same data source, like creating a cluster view, customer view, selecting row, customer ID, and name and blah blah all the stuff, all the columns available that created. So now I should be able to do the select star from cluster view, limit to, and I see the data. It basically runs that SQL query. Just like SQL databases RDBMS, you can create your own views. So this is the querying between different data sources. If you see here, I'm trying to use Hive, trying to select from the Hive orders, customer view, which we have directly created a view, and I'm trying to use a file, which is the clickstream, clicks number of JSON, and I'm trying to group by customer membership. I'm trying to select all the data types. I'm trying to select the customer membership type and summing on the number of orders are there, and using all these tables. So if you see the where class, this is where I'm doing all the joining part.
But it would support the ANSI style joins as well?
Yeah, it supports it as well. So if you see here, I'm joining the orders customer ID to the customer view customer ID, and I'm joining that with the orders customer ID with the user info. So the clickstream has a user info file, which I'm using it. I'm joining everyone using customer ID on their respective data sources files.
So while this is running, you mentioned that you can use the UDFs from Hive or other.
Yeah.
How does it do that?
So that's what query plan does it. So when you try to run it internally, I don't know what's internally what it's doing. The UDFs are functions that are kind of used at the query execution plan. In between my query execution plan when you're running it, it uses the UDF to do the serialization, deserialization on the drill bit, and try to send the data type back outside to the client. Even when you're using Hive, you should be just telling what jar it is there, where it is there, and it goes and picks up after a time. That's the same kind of thing. So that's a use case I want to show it. So right now, what's coming in the future for the drill? So we are kind of working on the drill for making more of JSON as any shape form. So when I say any shape, right now what happens is you can use a JSON, but you cannot do the flatten or anything on top of the other than arrays. Or if you want to say you have a big JSON object, you want to flatten it or make it more, use the flatten command, and it should pick up the data types on the fly. So I say select star, flatten all the JSON, and I see all the data types, and I can pick what data type I want, and should be able to create a own view or SQL on top of it. That's what we're trying. Security is not right now; it's not there. So every time, anything you run it as run it as a user. What are the user that drill has been started? That's the user who tries to use it. When you're trying to use it in Hadoop cluster, if you try it as a root, it's root. It's running as root. You can delete or update or anything you can do files. There is no security, which is coming in 0.9 version. And we are kind of working with a lot of vendors for new data sources. So trying to accommodate more in Teradata and SAS and all these data sources. We want to put it so that it can be extended to different, more extendable, improve multi-tenancy. That's what I talked about. We want to integrate with Spark and more coming with features. All the new technologies we kind of tried. Yeah.
So I assume that it was pretty much just a select insert only sort of operations, but does it support updates and deletes as well?
That's what I showed you, right? Create a query where I just run and create a new table.
Yeah, but that's a create table, right? That's,
Yeah,
that's a little different. But I mean, could you run an update?
Yeah,
on a,
there are some limitations on updates because you cannot do updates on high queries, and if you use MapR it does, not on all the data types. There are some limitations are there.
So kind of, but the underlying engine doesn't support it.
Yeah, that's right.
So on the views that you created, what's the persistence of that view?
The view data type, basically every when you use a drillbit cluster, it has its own internal data source, just like Metastore. When you create a view or anything, it kind of writes into internal data store. It's there on internal data store. You should, when you log in again, you will directly go to the internal Metastore and you should see the view there.
Have you seen use cases where you use drill for ETL or anything like that?
We have a customer kind of heavily, there are 3 customers, big customers, we're kind of heavily using for ETL purpose. There are some bugs, we're kind of figuring out all the bugs and everything. We have a customer where they are kind of querying on top of like 25 terabytes data sets. They're kind of uploading from the Vectica and doing the query on top of it, and creating the ETL process kind of queries, complex queries.
The question.
Yeah.
Let's say we have security on other sources, let's say Hive, for example.
Yeah,
So,
Hive. You on the Hive Metastore, you should provide your username password there.
we need to open it.
You open it, yeah. It's not like open it, but you are providing the username password on the Hive configuration. Basically, when you see the Hive storage engine, there are configurations you have set.
Yeah.
So those are configurations it tries to use it. In there, you can set the username password there. Right now, anyone can see it. In the future, like right now, it's in 0.8 version. In 0.9, we'll have the security enabled, wherein we'll be having impersonation. So impersonation tag will be there. So when you log in as a user, you should see your own Metastore, not for other people.
One more question. You said UDFs, we can use it from Hive.
Yes.
So can we build our own UDFs into?
Yeah, you can use this. That's what I meant. Like, you can use existing UDFs and write your own UDFs.
What languages? What?
It supports every language, just like Hive, Python, Java. So that's a question. You can directly all the data set I'm talking about, all the data types, all the information, what we do, everything, data sets. There are a lot of data sets. Like I spoke like 2 use cases. there are more than 2 data sources on the drill.apache.org. If you go to the wiki, it has all the information. It has all the sample queries, and I didn't cover most of them, but it has information about UDFs. It has information how to analyze your data types, how do data types are runtime analyzed. How do you determine when your data source are digging something? How do you determine data agility or where the data is there? All this information you should be able to get from the site. All that information is there.
I may have just missed it, or yeah, I'm trying to keep up. Like when you're looking at the MapR database and the data stored in JSON, is there a way the command line to reach in and grab specific elements of the JSON and bring them back out?
That's what it's trying to do. So if you see the query,
Yeah, I'm having a hard time seeing connectors. I apologize.
Yeah, no
I
problem.
missed that.
So if here the JSON, I'm not using any JSON here. JSON is what's JSON is extreme C. We can try it like C dot star from high. Let's see what data types are there. Again, transaction ID. Such. Yes. Yeah, take out the group by. You can see that there.
Okay.
So yeah, customer member information is coming from MapRDB, and this is coming from clickstream, which is not the hype. Clickstream is a file.
What is the performance level?
Sorry?
What is the performance level?
I don't have numbers. It's a similar, basically almost similar to Impala. Performance is there. So we're kind of trying to optimize it more, but right now it's comparable to Impala.
Under the covers, is it Java or is it C++?
Java.
Good job.
Thank you. We'll see everybody tomorrow. Make sure to grab lots and lots of sandwiches. Everything else. So.
On the MapR.com, we have a lot of trainings.
Free ones.
Yeah, sorry?
Free ones.
Free one. They're providing a new drill training. I just want to make sure that there's a drill training, which has all the information like how to create UDFs and everything is there. So you might want to go and take that course as well. Cool.
Thank you.
Thanks.
Thank you.